HeatNMof is a project which revolves around the targeted heat-triggered release of cargo. It is a Marie Curie action. To be more precise, it is an innovative training program, or ITN. It is made of a consortium of 13 academic and 4 industrial partners located in Spain, Germany, Italy, France, Belgium, and the United Kingdom. The ITN is designed to train 12 early-stage researchers, or ESRs, in the field of material science and biomedical application focusing on drug delivery systems, or DD. Although disease understanding has experienced a giant improvement, the efficient delivery of many potent drugs in the body remains a challenge, particularly for cancer treatments, because of drawbacks either from the drug or the carrier. The most considerable ones include toxicity, efficiency, and insufficient targeting, like the localized control and timing of the release. Hence, the search for a new delivery system. Metal-organic frameworks, MOFs, are 3D crystalline materials built from inorganic subunits connected to each other through polydendate organic ligands. Such solids are highly porous and tunable. Indeed, both the organic and inorganic units can be changed at will. Magnetic nanoparticles are suitable candidates for targeted drug delivery due to the suitable penetration depth of alternating magnetic field in tissues. On the other hand, the ability of plasmonic nanoparticles to drive photon to heat conversion has attracted much attention in biofields. Both photo and AMF heating processes rely on collective electronic effects. By combining the MOF and inorganic nanoparticles, we obtain composites. The highly porous biocompatible nanomorphs allow for the drug loading, and the release is controlled by the inorganic nanoparticles. When applying a lighter or magnetic field through heating, the drug is released, controlling not only the temporal but also spatial delivery. In order to optimize results, the workload has been divided. The first axis focuses on chemistry, particularly the synthesis of new MOFs and composite structures. The second axis focuses on the analysis of the new materials, particularly focusing on microscopy techniques. Transmission electron microscopy, TEM, can be used for 3D reconstruction, and microscopes coupled with photon or magnetic sources can allow a study over time of the drug release. The third axis is focused on biology, studying the cell's uptake of the nanocarriers, monitoring the cell function and the drug release upon irradiation to maximize drug delivery efficiency. Lastly, the management axis focuses on market study and patentability in order to increase the impact of the scientific research. HeatNMof was made possible thanks to the involvement of all our partners. For more information, you can find us on LinkedIn, Twitter, Facebook, or our website.